any lab analysis. After this, we want to secure the portion, that the small portion from the whole foods or the material can represent the product. So its ideal sample should be identical in all of the intrinsic property with the bulk of material from which it is taken. That means if the same product manufactured by the same company, let's say like a bread, when it's brought to the another state like Selangor, and then the same bread being distributed to Negeri Sembilan. So when we do the sampling, the same bread will represent the same intrinsic properties, exactly the same. Even there is a plus minus or SD, it's very minor, or what we can say is insignificance. Okay, what is sampling? Sampling is process of selecting representative materials to analyze. So the objective, to collect the food sample that are represent and to ensure that changes in composition does not take place between collection and analysis. Okay, sampling must correct, and also the duration of collection and the analysis taken place must be precise, must be controlled condition. So we don't want any contamination or any disruption in between that will affect the properties, like chemical changes, contamination, enzyme activities. So that's the objective of sampling. So the approach of sampling. What is the approach sampling? So the selection of representative sample and the combined process for sampling and the analysis must be based on the nature of the foods and the population of food being studied. If the foods is in liquid, so the analysis also must be conducted in liquid form. If it's in a solid food, so the sampling also must be in a solid food. So we can't change the condition from liquid to the frozen, bring all the way to the lab, then thawing it again to become liquid. So the analysis will be inaccurate. Okay. So the nature of measured properties. So the reason we're carrying out the analysis has been established to measure such as color, weight, the presence of extraneous matter, the fat content, or microbial count. These all factors will influence the outcome of the analysis. So the properties of food can usually be classified as either attributes or variables. There's only two classification for the foods. Either it's attributes or variables. We take a look deeper. So attributes. Attribute is something that a product either does or does not have that properties. Such as the product does or does not contain a piece of glass, or it is not spoiled. That means attribute anything that can contribute to the content or properties of the product. That's an attribute. So for variables, a property that can be measured on a continuous scale, such as example, the weight, the fat content, the lipid content or the moisture content of the material. That means something that we can measure on a continuous scale. So the variable sampling usually requires less sample than attribute sampling because the variable is already there. There is no add-on something like the attributes. Okay, that's the first characterization of the sampling. Second one, the nature of population. The nature of population of the sampling. So it's defined that the nature of the population from which sample are to be selected before deciding on the types of sampling plan to use. So some of the important points to be considered are finite or infinite population of the sampling. Number two, continuous or compartmentalized population. And the last one is homogeneous or heterogeneous population. It can be combination, two of it or three of it. Okay, the explanation for finite or infinite population. A finite population, it has a definite size, such as truckload of apple or tanker full of milk. Okay, remember, truckload of apple or tanker full of milk. So analysis of finite population usually provide information about the properties of the population. There is a finite population, something that carry the product or the sample or container for the sample. There's a finite population. And infinite population, it does not have definite size, such as conveyor belt that operates continuously from the raw product until to the end product. So analysis of an infinite population usually provide information about the properties of the process. Okay, it's continuous process that carries all the sample in terms of the production. To facilitate the development of a sampling plan, it is usually convenient to divide an infinite population into a small number for easier to us to do the sampling. So we divide from infinite population into a number of finite population, such as all the product produced by one shift of worker or all the sample produced in one day instead of the production on conveyor belt for one day. That's infinite population. So we cut off or we make it smaller. We divide it to become the finite population or easier to us to do the sampling. So number three, continuous and compartmentalized population. A continuous population, there is no physical separation between the different parts of the sample, such as the liquid milk or oil stored in a tanker. So all this sample is a continuous population. It's mixed together, liquid milk or the oil, cooking oil. Okay, it's continuous population. Then we have a compartmentalized population. From the names we know there is a separator to split into a numbers. Okay, such as a box of potato chips in a truck, or box of apple in a truck, or a bottle of tomato ketchup moving along a conveyor belt. So the number and the size of the individual subunit determine the choice of particular sampling plan. So from here, from infinite population before this, like conveyor belt, actually is an infinite population, is it? From raw until the end of production. But when we are doing a compartmentalized population, we can get the smaller number. Then we can have a particular sampling plan, either systematic sampling or random sampling, because it's become smaller. But it still represents the whole population when we are doing food analysis. So homogeneous or heterogeneous population. Homogeneous, the same sample. Okay, the properties of the individual sample are the same at every location within the material. Such as example, the bread is from the same factory. Heterogeneous population, the properties of the individual sample is different within location. Let's say the same food like the bread, but in a different location, it will be different based on the different location of production or the factory. So for homogeneous foods, actually the foods that are manufactured or processed, such as milk and milk product, that's a homogeneous foods, the same category. Usually the homogeneous foods product are produced by a few major or main food manufacturer. So like a big company, they can produce the homogeneous foods, a big number of homogeneous foods, but they still can do the food analysis accurately for each of the product because of the sampling plan, and also the sampling process is correct from the beginning. So for heterogeneous foods, it will include food and food product that are from cottage or small scale industry, whereas fruits and vegetables, meat and meat product, poultry, and so on. Okay, all cooked food like a traditional Malay kuih and snack, cooked dishes and meat are also as heterogeneous because it's mixed up from different category or types. That is a heterogeneous foods. It's quite difficult to conduct the sampling process and also the food analysis process because it will represent the different result. It will produce the different result, such as nasi lemak. Okay, nasi lemak can consider as heterogeneous foods because nasi lemak in Selangor will be different from Malacca, from Perak. So that's why we consider it as a heterogeneous foods because it's produced from the small scale industry, SME, or in Malay we call it as a IKS, industri kecil sederhana, because they can produce, they can control the benchmarking, the standard for each product, same for the all production. Okay. Are you with me? Can you get it?
Yes.
Okay.
Yes, Prof.
Okay. So we go for type of sampling methods. So this is important because it will represent At the end of the day, the outcome of the analysis, it will influence the analysis procedure. So type of sampling, we have first random sampling. We can take from any sample at any time. So the subsample are chosen randomly from any location within the material being tested, but still must be the same food product. Random sampling is often preferred because it avoids human bias in selecting sample and because it facilitates the application of statistics. That's why the random sampling become the main sampling method, because there is no bias, there is no human bias. At any time, the auditor or the food technologist can pick up or choose the sample from any production process or compartmentalized container. The second one is systematic sampling. So the samples are drawn systematically with location or time. For example, every 10 box in a truck may be analyzed, or sample may be chosen from conveyor belt every 1 minute. Or the lucky draw, simple. The lucky draw for systematic sampling. The lucky draw for the attendance of today's class. So every 10 students that check in the class, we get extra 1 mark. That's example of systematic sampling. Very, very systematic in terms of selection. So this type of sampling is often easy to implement, but it's important to be sure that there is no correlation between the sampling rate and the subsample properties. So still, we must avoid the bias. Okay? Must make sure there is no correlation. The third one is judgment sampling. The subsample are drawn from the whole population using the judgment and experience of analysis. Can any one of you give an example for judgment sampling? Any one of you? Volunteer? Part 4, one from part 4 and one from part 6. Just throw your idea for judgment sampling. Give an example for judgment sampling. Part 4, part 6. Come on. Don't make me call up your name.
So, judgment sampling, for example, from the legs.
From the?
Legs. Taking the sample from the legs.
Okay. What type of sample you want to take from the leg?
Soil or water.
Okay. Type of water. What do you want to analyze from the water? Anyone? Any of your friends want to help?
To
analyze the amount of chemical in the water.
Chemical in the water. Okay.
Or pollution.
Okay. Okay. This from part 4.
Yes.
Okay, part 6. Senior. Can you give an example for judgment sampling?
The first one is from the part 6.
For the? Oh, from part 6. Okay, part 4.
We take a sample from the oil tank.
Oil tank, okay. So what we want to analyze from the oil tank?
We want to make sure whether the oil that we taken has or has not contained any discriminate ingredients or something that it should not be in the oil.
Okay. Okay, thank you. Okay, thank you for both of you. There is something missing. Okay. There is something missing in the explanation or the answer from your friends. Okay. The judgment sampling must be conducted by the expert from that area, from that field. Because there is a large population of sample. So it must be correct to conduct the judgment sampling to avoid the loss of time, the chemical changes, the food contamination, based on their experience, expertise to conduct the sampling. Maybe your friends get the idea, but the way of present the explanation. Okay, we take a look at one container. Okay, one container in a port that shipped from overseas. One container of dates, kurma. Okay, arrive in our port, Port Klang. So the expert or that company, let's say from company of Yusuf Tayyub. So how he want to make sure that sample from that container is good, fresh, safe for consumer before they agreed to buy and to distribute to the market, to hypermarket, before it's come to the consumer. So the expert will be face difficulty to conduct the sampling process if it is his or her first time experience. From one container, do you want to do food analysis for each of the box in the container? For sure, it will take more than a week to complete the analysis. So the easiest way for the expert to conduct the judgment sampling, he or she will take the sample or the population, like what we learned before, the compartmentalize, the box or the container that near the door of the container, because that's area that get the less of air conditioner or air circulation. It get the highest heat during the shipping. So in terms of the food spoilage or food contamination, the first product, the first batch that will be affected is the dates near the door. Okay, that's based on the experience. So the judgment sampling only being conducted by the expert of the area. Same goes to the wine. Only the expert can judge, can evaluate the best wine in the world, because he know from the smell, from the taste, rather than have to do analysis from each of the bottle of wine. Okay, this could be the easiest subsample to get to, such as the box of product nearest door of a truck. Alternatively, the person who select the subsample must have some experience about where the worst subsample are usually found. Example, near the door of a container or the warehouse where the temperature control is not good. It is usually possible to apply proper statistical analysis to this type of sampling, since the subsample selected are not usually a good representation of the population. So this for judgment population. So that's for part 1. So we take a break for 5 minutes before we continue for part 2. Okay? So any question until now for part 1? Any question or any feedback?
There's a question in the chat box, Prof.
Okay. How we measure for the attributes? Is there any specific tools for that? So normally for attributes, what we do, we must eliminate first the attribute. We must eliminate the attributes in the sample. Okay? Eliminate first. Such as we got the metal detector, we got the separator. So eliminate first, or take out the attribute first, Then we can conduct the food analysis. Normally the attributes can also known as a contaminant. The physical contaminant of the product. We can see by our eyes. It can be physical or chemical. Okay. Okay, we continue with part 2. Okay, preparation of laboratory sample. Once we have select the sample that will represent the whole population, we prepare for the analysis. It must be done very careful in order to make accurate and precise measurement. Okay, to avoid mistake, to avoid repetition of the analysis, and also the chemical reagent. Okay, first making the sample homogeneous. Must mix together, must be homogenized. The sample must be homogenized. Okay, the food material within the sample portion or within individual units are heterogeneous. So make it as a homogeneous. The reason is it is usually necessary to make sample homogeneous before they are analyzed. Otherwise, it will be difficult to select a representative laboratory sample from the sample, such as we want to analyze nasi lemak. Okay, the nutrition content for nasi lemak. Nasi lemak, at the first place, is a heterogeneous. We got the separate nasi, anchovies, cucumber, egg. Yeah, that's a heterogeneous. So when we do the food analysis, we blend together, mix it together to become homogeneous. Then we make it a small amount to be analyzed that will represent the whole population of the sample of nasi lemak. Okay, a number of mechanical devices has been developed for homogenize the food. Either it's solid, semi-solid, or liquid. We can use grinder or mixer, slicer, blender, depend on the properties of the sample. After we make it homogenized, we reduce the sample size. Make it the small amount. Okay, once the sample have been homogenized, a small, more manageable. Okay, we can manage more manageable portion for the analysis. This is referred to a lab sample. It will have properties which are representative of the population that I described before. Okay, there's a few methods for reducing the size. We can perform manually by coning and quartering technique. Okay, this technique called by coning and quartering. So how the coning and quartering take place? Okay, we take a later. Second one, we form a conical cap head of granular or powdered and spread into a circular or the flat cake. Okay, this is for coning and quartering. We make a conical cap or cone of a granula. We put a sample in it, then spread it into the circle shape. So the cake is divided radially into quarter, and two opposite quarter are combined. Okay. Then the other two quarter are discarded. The process is repeated as many times as necessary to obtain the quantity desired for final use. Such example, 250 gram per milliliter. Such example for that nasi lemak. Okay. After we have grind, blend, homogenize all the heterogeneous nasi lemak to become homogeneous nasi lemak, we put in a cone or cap, conical cap, then spread into the circular shape like a cake. Then we divide by 4 area. Okay. So the cake is divided radially into quarter, and the two opposite quarter are combined. So the other two is discarded. We throw it away or put it aside. Then the process is repeat until we get a small quantity of the final use. So what's the problem in sampling? There's still difficulty. There is still obstacle in terms of sampling. First, it's difficult in obtain the representative sample. Then, loss of plant material during the sampling process. We are unable to avoid the removal or extraneous material. Enzymatic changes. Okay, enzyme changes, the metal contamination, and also the changes in unstable component like pupa component, chlorophyll component is very sensitive to the environment, either to the light, to the air. Okay. So how we prevent the changes in sample? So once sample has been selected, we must ensure that it does not undergo any significant changes in its properties from the moment of sample until we carry out the analysis. So the possible changes are due to enzymatic, chemical, microbial, or physical changes. Okay, these possible changes, like what your friend asked in the checkbox, these can be the attributes to the product or to the sample. A number of methods that can be applied to minimize these changes as follows. First, we have enzymatic inactivation. We must ensure there is no enzymatic process occurred in the sample. So the problem, many food contain active enzyme that can cause changes in the properties, like protease, cellulase, lipase. There's an enzyme in the sample. So the action of one of these enzymes alter the characteristic of the compound being analyzed. So it will lead to the erroneous data. Therefore, it must be inactivated or eliminated. So the method is by freezing and drying to lower the water activity. Or we use the heat treatment to denature the enzyme. And chemical preservative. There's some chemical or very specific chemical to preserve the enzyme to take a place. So the method used depends on the type of foods being analyzed and the purpose of analysis. The second one, we have lipid protection. Problem, the content of unsaturated lipid may be altered, reduced by various oxidation reactions. So exposure to light, eliminated temperature, oxygen or pro-oxidant. So some sample might have the high unsaturated lipid, content that should be stored under nitrogen liquid or some other inert gas. Okay, antioxidant may be added to retard oxidation process provided that the antioxidant will not interfere with the analysis. So at the end of the day, the content, the nutrition analysis not interfere or influenced by the antioxidant process. The third one is microbial growth and contamination. We don't want the microbial growth and contamination take place. So method by freezing, drying, or heat treatment. Then we have physical changes. Okay. Such as the water or moisture may be lost due to the evaporation, due to the condensation. The method, we control the storage of the temperature. This is a summary of the method to preserve the sample. If it is a light sensitive sample, we wrap it with aluminum foil or place in a opaque container. For unsaturated lipid, we store under nitrogen, enzyme altered compound. So inactivated using heat treatment, microbial growth, freezing, drying, like what we have learned before in food microbiology subject. So storage of the sample, sampling preparation usually mean that it's more convenient to store the analytical sample. At least 3 sample replicate should be stored. Normally 2. That's why we call duplicate. So we do it 3. Okay, 3 sample replicates in a controlled condition of temperature. Okay, storage must be accurate. The container must be properly choose. Okay. Then we go to the evaluation of the analytical data. So after all have been taken place with the correct or what we call precaution measure, then we conduct the data analysis. Normally we doing 2 or more measured per sample to make sure the data is accurate. So we got the mean. After that, we got the mean reading, mean result for the measurement. Okay, try to avoid systematic error in the analytical method. So that's why in the lab we have the control or the blank before we conduct the actual analysis. So must be accurate. Sometimes there is absolute error in terms of the data analysis. So absolute error can be obtained by the difference between the true value and the measured value. So let's say we have the standard value, then we have the measured value. So the difference we call by absolute error. So this accuracy and precision, you have learned this in physics before, accurate and also the precise. Okay, measure of the data, dispersion, standard deviation. There is SD, always as the SD, what we call by plus minus. So even the same sample been given to you, unfortunately during the MCO we can't conduct the actual lab analysis. But if there is actual lab analysis, if we give you the same sample, still from one group to the another group, we have the different data output. So the difference is called by standard deviation, plus minus within the groups. Okay. Then we have another parameter that we call by coefficient of variation. So the difference between each group can be considered acceptable if it's below than 5%. Okay. The CV, coefficient of variation. CV below than 5% is considered acceptable. What the error? What the source of the error? Sometimes by the personal error, by the random error, or the systematic error. So rounding of numbers normally in a lab only by 2 decimal point. So we must round up the numbers. So standard curve, like what you have learned in the mathematics, y equal to ax or mx plus c. Then from the linear regression, we can mark the scatter of the data output. So take a look. Is it near the linear regression or is fall under the standard curve? So when we reject the data, after we got the data, but some of the data is not valuable, we must put it aside, or what we call as a reject the data. When you came across the value that does not match the others, can you reject the value and not use in calculating final result? Yes. We can conduct the Q test to reject the aberrant value by using this formula. This is a Q value for rejection of result. For example, we have 3 observation, 3 numbers of observation, 3 data, 3 figures of data analysis. Okay, the Q of rejection is 0.94. That is 90% of level. So it's below than 0.94, must be reject. Okay. Okay, that's it for today. For sample, for sampling. Okay, sampling, preparation, and preservation. So maybe we can take a look. In terms of the sampling technique, there is a lots of video that you can find in YouTube to enhance your understanding for today's topic. Okay, so maybe we can take a look at 1 or 2 short video. Okay, this proximate analysis, septic sampling, food sampling instructor, food preservation. Okay, we make it. Videos. Okay, this type of sampling is already narrowed down to very simple understanding.
Doktor, sepatutnya ada sound ke?
Kenapa? You all tak dengar ke?
Tak dengar. Ke saya je?
Oh.
Tapi saya tak dengar.
Saya
Yang lain?
pun.
Lah, kenapa tak cakap? You all tak dengar. Okay. It's okay. Tak apa, nanti I will choose the suitable YouTube video that represent today's topic to be uploaded in the near future. Okay. Maybe there's something wrong with the setting. We try another one. You can see the video but can't hear the voice, the audio. Okay.
Sebab Prof pakai headphone kot.
Oh, ya, sebab saya pakai betul. Nanti saya cuba buka sekejap. Saya tak pakai lagi bising you all dengar ni. Sekejap dengar tak?
Tak dengar sih. Prof present tak rasanya dengar kot.
It's okay. So I will upload in the near future after this. Okay?
Okay.
Okay, Prof.
Okay, that's for today's lecture. we end with Tasbih Fikrah in Surah Al-As. Okay, don't forget for your attendance in the near future. Okay, have a nice day. Bye.
Okay, thank you,
Thank you,
Prof.
Dr.
Thank you, Prof.
Thank you, Prof.
Thank you, Prof.
Thank you,
Wow.
Prof.